Our first talk this evening is by Dr. Tok Wee Hyong, who will be speaking on Thriving in the Era of AI. Dr. Tok Wee Hyong graduated from NUS with a bachelor's degree in computing in 2000, followed by a Master of Science in 2002, and later earned his PhD in computing in 2009. Today, he is the Partner Director of Products and AI at Microsoft, where he plays a key role in driving cutting-edge innovation in artificial intelligence. In this session, Dr. Tok will walk us through the evolution of AI, its transformative impact across industries, and how individuals and organizations can adapt to unlock new value through AI-powered innovation. You'll hear about the importance of quality data, key breakthroughs, and why a growth mindset and a learn-it-all attitude are essential for success in this fast-changing era. Dr. Tok, please.
So, first of all, huge thank you, to School of Computing, the Office of Alumni Affairs, and many of the fellow colleagues for organizing this event. And more importantly, I think every one of you coming, whether it's after work or after a long day of work, to be here together on the series of talks. And I think when we were having a discussion on what kind of topic we should share and so on and so forth, one interesting thing is, if you look across, whether it's in Singapore or globally, there is a lot of talks on, the technological advancements of AI, whether it's in research communities or whether it's in commercial conferences and so on and so forth. And this talk, of course, will touch on some of that, but I think the point there was, the back of my question for many of us is, how do we thrive? Thrive in the sense that, well, we do the work that we do every day, but we get complemented with what AI can do, right? And we get to become, we increase our value in the whole value chain, if you will, right? And that's why this talk is called Thriving in the Era of AI. And the other interesting thing is this month had been a really exciting month. Just last week, finally, after many years of, with a lot of help from a lot of government agencies, from EDB to many other organizations, including NUS, and so on, right? We finally landed Microsoft Research Asia in Singapore with a lot of strong collaboration with NUS School of Computing, and at the same time also with some of the local groups like Sing Health and so on and so forth on using AI to push the state of art for precision health and so on, right? And that took many, many years. We're so happy that MSRA is finally in Singapore. And hopefully, as Peter Lee, who was the president of Microsoft Research, said during his speech last Thursday, was that this is just the beginning, right? And a lot of times when a big, huge research lab lands in a place, it set forth a whole decade of kind of collaboration, whether it's with the industry, with academia. So that was really exciting. The other thing that has happened, right, is over after the MSRA launch on Thursday, Friday, Saturday, Sunday, at the School of Computing, right, there was the AI Summer School. There was a collaboration of IMDA, Microsoft, School of Computing, right? And the conversations was just engaging, right? From a lot of topics, whether it's an industry lens to it, or whether it is with academic lens to, thinking around reasoning, some of the latest topic around agentic, multi-modal AI, and so on and so forth. And I came back actually to School of Computing just yesterday to do the closing remark. But it's also fascinating to see how School of Computing has grown from Com 1 to Com 4. So kudos to the team for getting it there. So that's how I wanted to start this. But I think one thing that was discussed during every conversation that I have, right, and even though I'm back actually in Singapore for vacation and personal leave, I still spend a lot of time meeting a lot of the agencies and many people on different kind of conversation. But one common thing that comes about is, while we want to use state-of-art models, while we want to build applications that support our staff, our colleagues, and so on and so forth, many a times it's often about how do we measure the impact delivered by AI, right? And of course, many a times we all belong to a commercial company, academic institution. There is the bottom line, right? There's the commercial part of it, but there's also the societal part of it, right? On how AI will truly change life, it will truly change the way we work, live, and play, right? And often, when we have this kind of conversation, it often reminds me of this was a picture that I used in the talk probably many years ago, even before this Gen AI came along. I think Prof. Who has seen this before, right? This lady is actually Florence Nightingale, very well known in healthcare and so on and so forth. And what is unknown about her was that she is actually an active contributor, or in fact she publishes a lot in statistical journals and so on and so forth. And this was a quote, imagine, this was a quote so many, many years ago, where there is discussion around good quality data. More importantly, properly interpreting good quality data. And the last part is really powerful, which is it can be a power of good in all areas of medicine and health, right? And if you fast forward so many years till now, isn't this very true even in the context of kind of healthcare conversations that we have and so on and so forth, right? And so I wanted to start off with this, but also showcase some of the work that she did, right? This Nightingale Rose diagram is seldom seen, but it's essentially a way of visualizing data. But it was her way of convincing her stakeholders, right, when she moved on to a place called Sanctuary, that there was so much fatalities or death in the front line of the battlefield. And because of good quality data, and of course that time she doesn't talk about Gen AI, she doesn't talk about large language models and so on and so forth. But even though it's a more statistical case than AI case, right, because of data and because of carefully analyzing it, the kind of death that happened reduces from 43% to 2%. But she was able to uncover a lot of key factors on what would change it, right? And isn't this about the kind of impact that we want? You want to change life, you want to make an impact, but you want to make an impact for the kind of scenarios within which your technology is serving, right? And I felt like this is true, and that's the reason why I started with this. And I think the point here is how do we make a difference in people's life, right? And one thing that's really heartwarming is that Singapore has become a really vibrant AI ecosystem, right? With support both from the industry, from the public sector, the governments, and a lot of this kind of AI training offered across all academic institutions. And in fact, one thing, and why do we at Microsoft, why do we think about this that way, is because if you look at it, this was a recent quote from Satya, which really alludes to even that conversation that we had on Florence Nightingale, is the real benchmark of AI progress is not whether it makes a real difference in people's life, right? And here they just covered a specific few industry. But that's the point, right? That's what, whether it's AI or whether it's technology, that's essentially the kind of goal that we want to get towards, right? And so we switch gears on, let's sample the progress that AI have made. And many of you might have already seen, or kept abreast of all these things that's happening. Now, what is fascinating is that, every time I'm based in Seattle, and so every time I take a transatlantic flight, there's a direct flight from Seattle to Singapore, about 16 hours. From the time you board the flight and you land, several things can happen. New AI research is published. Sometimes new foundational models are released. And what you're preparing your slide for say, a conference and things like that, will have to completely, not exactly completely be outdated, but you have to update the content by the time you land in Singapore, right? And over the last 2 weeks or so, I'm sure some of you have seen work across OpenAI and Google, right? And here I'm speaking not in the context of a Microsoft hat, right? But the point there is, with recent advancement in AI and in reasoning and so on and so forth, tremendous progress has been made, right, to use some of this work to solve, for example, IMO problems or International Math Olympiad problems. Now, the good news on all of this work, and if you keep on reading on what is happening in the Google front, besides the authors of this paper and of course many other works, right? Recently they took a picture. One of the guys contributing to this effort is a Singaporean called Yi Pei, who used to be a CEO of a company called Recur.ai based in Singapore. He went back to, Jeff Dean was here a while back, right? Jeff Dean convinced him to go back to Google DeepMind. And the first project they went back in DeepMind was to solve this problem. So fascinating work. And the point there is, we talk about AI will change every field and every industry, but the point there is, AI has changed every field and every industry, right? And I've been back for the whole month when I meet people and have chats. Whether the person was a tech person or non-tech person, they want to have a conversation around AI, which is very fascinating. And just to put it case in point, traditional fields like physics and chemistry, these are fields where you require years of domain expertise, not less to even win a Nobel Prize in chemistry or physics, right? And in the last set of Nobel Prize that was won, a lot of the people that is here and the names that you see here, they are all computer scientists. They were not chemists, they were not physicists, but they collaborated with domain experts from chemistry and physics to win this. And this is a huge testament on how the field has progressed, right? And more importantly, every field is being disrupted, and the time for AI is now, right? And so the point there is I'm just giving you a few examples where AI enables creativity, right? And I wanted to showcase some of the great work that Singaporeans globally are making, right? And the first one is really a lady called Yi, right? Yi Hui. She's based in the Bay Area, and the work that she does is, if you've ever been to some conferences, you might have seen a presenter that's presenting, and on the side there will be a person that's drawing and visualizing, summarizing the content of the conference. And she actually started out doing that, right? At conferences and in some of the events where the Singapore team from the ministries or whatever was in the Bay Area. She's the one that's always drawing, and she presents very compelling and powerful visual summaries of the event. Really awesome work. And so one of the things that she did over the last 1.5 years was to partner with Tia, right, and others to take a lot of the work that she does, and now she's able to use AI to be able to listen to the conference and someone talking. And all these things that you see here is all now generated. That's one case in point. The other case in point is a story shared by one of the also computing alumni, where he is the CMO for one of the local companies. They used to spend a lot of money doing a lot of copywriting, right? And they work with agencies to do that. And over the last 1.5 years or so, they have transformed it where they still balance and work with some of these agencies for copywriting. But a lot of the marketing budget is now in paying for all these tools to be able to generate copywriting much faster, right? And so this is just one example. I'm sure you have your example as well. The other area that's interesting is, which is a top of mind for many topics, right, is AI in education. And what I'm going to show next, right, and this is, the source comes from CNA, so I have to give credit to them, right? It's really AI that's happening in Singapore today at early schools or preschool level, but it's making a difference in people's life as well, right? And so this is one video which I'll play.
There's a new kid on the block and its name is AI. This language learning program highlights each preschooler's mistakes and customizes fun coaching until they get it right. 2 years with this AI tool, and this preschool operator has seen its students learn up to 10 times more words. Still, it's making sure there's a healthy balance between man and machine.
Teacher teach the lesson. Definitely, we're not going to change that. But a teacher in a class cannot provide one-to-one assistance to so many children. So AI comes in as a revision tutor to revise the things that the children have learned from the teacher. And this combination of human-AI collaboration, it works wonders.
Even then, experts warn that tech in such a young classroom can be a hazard.
We also need to ensure that the digital activities are developmentally appropriate. That means avoiding passive screen time and focusing on interactive, purposeful learning. So a balanced approach is key because our children still need plenty of time for physical play, social interaction, and of course, creative exploration.
So I think one thing that's really heartwarming is this is a Singapore use case. The people that develop the technology is Singapore companies, right? Companies like WebSpark that Chichu is leading and so on and so forth. But the point there is, today, because of the thriving AI ecosystem that's in Singapore, right, which took years to get to, right, from the National AI Strategy 1.0 to 2.0, we have the talent and we have the ecosystem to do AI, not just in Singapore, but in ASEAN and so on and so forth. So it's fascinating work. Now, the third piece is because, Even though I'm saying I don't have my Microsoft hat, I have to show you some things that Microsoft is doing as well. And this is really work, and this is probably already about 1-2 months old, on AI enabling how developers to thrive, right? And one fascinating thing before I show this, and just to make sure that it's balanced and not biased to just Microsoft, this afternoon I was with one of the largest system integrator in Singapore on a similar kind of conversation, but they built their own similar technology. I won't name it, some of you might be aware. And it's all in-house built in Singapore to empower their about 2,000, 3,000 workforce to thrive in coding and be able to deliver or do service delivery to their clients, right? So what you see here, even though it's a Microsoft use case, today Singapore companies are actually building this for their own organizations as well, right? So let's take a look.
You can now assign issues to GitHub Copilot in the background, freeing you up for other tasks. Let me show you. We're building a website for Copilot Airways where users can book flights. But the form doesn't have any input validation. Taking a look at the issue, it seems straightforward, so let's assign it to Copilot. Copilot reacts to the message, showing that it's aware of the request and is taking action. Copilot then creates a pull request behind the scenes and gets to work. Copilot forms a plan and keeps the pull request description up to date as it progresses, working asynchronously while we get on with other tasks. Now, we believe a human in the loop is important, and we wanted the review experience to feel natural as any other pull request. So as you might expect, you can review the changes and add comments like you would with anyone else from your team. Here, Copilot acknowledges our comments to create a GitHub Actions workflow and iterates on the task. When working with Copilot, or even afterwards, you can view the session and understand how Copilot is approaching the problem. In this example, it explored the repository for existing workflow files, formed a plan, and created a new workflow file. Copilot can also run tools like linters, build, and tests to check the quality of the code it's suggesting. Now, like any other AI-generated code, you should review the code before executing it. This is why you will see a button to approve and run before executing any GitHub Action workflows. Now, as we've reviewed the code and our quality checks have passed, we can mark the PR ready for review. But you're probably wondering how it turns out. Here it is. Our form has been updated with real-time validation and an improved user experience. Let's get that merged. Thanks, Copilot. To learn more about the Copilot coding agent, visit gh.io/copilot/coding-agent.
So I think one fascinating thing here is this notion of coding agents, whether it's from a company like Microsoft or some of the startups, whether it's locally or in the US or any parts of the world. These are very real, and a lot of the engineering teams or developers team are starting to use this kind of technology to improve their productivity. And in Singapore, right, as I was telling you, this organization that I was talking to this afternoon are using this for their 2,000, 3,000 workforce of developers as well, right? So this is getting very real. But before I get on the next slide, I just want to share like an interesting story that even before all this coding agent came along, I remember about 4 or 5 years ago, before even all these large language models and generative AI came along, there was a specific team at Microsoft where everyone wants to meet Tony on the team. Right, Tony seems a new hire. So someone in the address book created some guy called Tony. Right? Why? Because this Tony was the most productive member of the team. And every time someone sends him email 24 hours a day, he'll respond by showing this and that. And so at the, like when you bring the team together, you have team parties and everyone wants to meet Tony. That time we don't have all this agentic technology. And it turns out that one developer on the team actually coded Tony by observing all the emails that comes in, right, and all the things that's posted on the chats and so on and so forth, and created a scripted response, right? And only after 1 year, when no one had ever met Tony, then the developer came and said, hey, I'm the one that did Tony. But the point there, at that point in time, it was very well scripted things, right? But it's already enabling the team to be productive by saying, hey, I have this incident, can you go fix it? Tony will reply, yes, on it immediately. A few minutes later, he will have fixed it or have pinged the right subject matter expert to fix it. Right? Now imagine that was before what a lot of the recent progress in technology has enabled. Now with a lot of these co-pilot agents or coding agents, right? It is changing how we develop software across every role in a software development team, right? From designers to product managers to testers to developers. And so this is just going to keep getting accelerated. Now, and I'll fast forward, and because most of you are experts or becoming experts in AI, is most of people, when we look at how did we get here, right, there's usually three or four dimensions to it. One is, of course, tremendous effort around the world on infrastructure, right, and hardware. And you have seen, like, you know, in the past 1-2 months alone, announcement made by many companies on building AI supercomputers and so on and so forth. And then, of course, there's progress made, right, along algorithms and people thinking beyond what the transformer is and is not. But usually in all this conversation, most people will ignore data, right? But if many of you have done an AI project, right, getting the data right is actually the most important step. The rest is actually much easier, right? And so I'll just frame it in that and just give you sampling of things that we have looked at, right? And this is essentially inside the AI infrastructure at Microsoft. We think about it from compute, networking, and storage, and most of these are better tested over the last 4-5 years, accelerated by our collaboration with OpenAI. Right, so just an example, if you look at the AI computers from 2020 to 2024, right, in the past you talk about V100s GPUs, right, at the point Azure was the number 5 supercomputer in the world. By November 2023, which is 3 years later, right, just look at the speed of progress, we had about 14,800 GPUs, right. Now, by May 2024, and then I remember this is already a year ago, we were building equivalent of these supercomputers every single month, right? And now, of course, the size of this has significantly grown, right? The recent one by another company, the size of their AI supercomputer is the size of Manhattan, right? Which is huge. And of course, just as a data point, right, the training has also significantly decreased through advancement in, of course, hardware and algorithms, right? Now, just to put in perspective, the amount of GPU memory needed, right, for whether, you know, dealing with 1 billion parameter, 175 billion parameter, right, and today, of course, we talk about trillions of parameters, has significantly increased, and so hardware has caught up with that, right? And just as a layout on, you know, where is it used on the NVIDIA 800, and by now 800 is already pretty dated, right, and you need to use all. Now, the other interesting thing is, many of us who play games, we're very familiar with GPUs that is in our board, and we already started doing liquid cooling. Like if you build your own GPU supercomputer at home, temperature is about 56 degrees. Of course, in Singapore, it's going to get hotter, right, because of the hot temperature. Now, think about taking that, right, and this is just a daily-generated image. The operating temperature in a data center needs to be kept around 30 degrees Celsius. And so a lot of effort has been spent on cooling, right? And so some of the work that we did, Maya is essentially our own customized board. It is a liquid cooling system where the Maya board has actually 4 Maya accelerators, and each one of them you see on the top, right? And it's liquid cooling, liquid going in and liquid coming out, and everyone has their own custom design. Now, the other good news, which is also very heartwarming, in Singapore, there are groups that are already building this on their own, similar to what we have done on the Azure journey, right? And in fact, one group, when I met the CEO probably last week for lunch, they just turned on that first cluster that's liquid cooled. Fascinating work, right? And the point there is, how do you solve this to be able to save water, get the system to cool, and to save energy at the same time, right? Now, to put that in perspective, this is how it looks like before we deploy it to the data center. What you have on the left is what we call a sidekick. It's the one that's cooling traditional Maya servers, right? And of course, this is something that was done a year ago. Our technology has moved beyond that, where we want to remove the sidekick, right? And everything is just within the rack itself, right? Fascinating work. Now, other things that we did, and of course, this just shows you what is there in the data center. And these are NVIDIA 800 GPUs, right? The cyan cable that you see there are the InfiniBand cables, right? There's enough InfiniBand cable in a single data center to wrap around the Earth 5 times, right? And what is fun is whatever that you see here is like a subset. We build many of these every single month, right? Because of customer demand, right? Now, the other thing is, it's not all about hardware and GPUs and that whole race around that. We also have fun, right? So our data center technician actually had a lot of fun in, it's not just getting the rack in and installing and turn on the power. Laying the cables is actually another fascinating thing. Remember, the cables can wrap around the earth 3 times, right? And so at the Microsoft data centers, the technicians spend a lot of time on how to lay cable efficiently with limited budget, right? And so they actually 3D printed this thing called, that will take the cables and it will then automatically lay the cable so that they can get them to do other works, right? It's all 3D printed. They call it boats. That's why it's called Project Boat. But these are the fun that our technicians are having in the data centers, in just making sure that the speed at which you spin up data centers has tremendously increased because of this huge global ask on demand, right? And it actually saved 3x the time because of this innovation, right? To lay cables, which is important because that's one important step before you can turn operational a data center, right? Fun work. So it's not just about hardware, right? There's a lot of innovation done on just simple things like laying cables, and you see it pulling the InfiniBand cables, right? Very, very fun work. Now, and of course, we're going to fast forward. Many of you already know the history of this. The point there is we have moved a lot beyond that, and this was like the early work. These are actually dogs and cats at the Holland Village area, where they had a dog park, and so every day I took some dogs and cats just to prepare for this presentation, right? But the point there, it was essentially the first work was around looking at internet images and finding dogs and cats, or being able to classify or categorize them, right? Tremendous progress made. This is an example of projects that I've been doing pre-large language models days. At that point in time, all projects was computer vision related, right? Most people are not interested in text. And suddenly now the world has changed. Everyone wants to talk to you about text, right? And that's also tremendous progress made. And of course, you have seen works around the transformer, classical paper on that, right? Lots of early language models was all around Muppets, right? Pre the models that we see today. And the point there was, we have come a long way since, right? One is, of course, scaling law. Everyone is aware of that, where compute data, algorithmic advances are the 3 fundamental factors that guide the progress of our what we call modern machine learning. And scaling law, just like Moore's law, right, is driving today's AI revolution. And that itself is also fascinating, where AI performance is doubling roughly every 6 months, right? The amount of compute used to train notable model has grown 4x every single year, and this is continuously being accelerated. And of course, we all know when the world met ChatGPT. We have never looked back since then, right? I think that is the moment when people started realizing the power of large language model demonstrated in a way where you can throw all kinds of crap to the thing and it seems to make sense to you, right? Llama, huge progress, but this was Llama up to, whatever the versions that they released up to now. And as you saw, right, that specific company is also now launching a team called the Meta Superintelligence team with some very impressive hire. Now, the guy that is now the chief scientist for the lab, the Superintelligence lab, graduated a PhD probably 2-3 years ago, right? Fascinating work. And so the world is getting disrupted, even in the fields that we love, right? And of course, lots of discussion around closed source, open source model. But the point there is a lot of this open weights model is facilitating research, right? It's facilitating both commercial and academic institutions to be able to do innovation. Case in point, right? AI Singapore that's affiliated with NUS. Leslie has been doing a lot of work on getting Sea Lion to where it is today. Now today it's adopted and trained across Indonesian models, recently released Thai models. And so this is amazing. The other perspective is these are just logos from all the companies that have sprung up since this whole AI revolution started. All in all, there's about 2,000 plus companies. 2024 alone, there was about 500 plus companies added. And in this year, it's actually accelerated, right? And so lots of opportunities for us. And then finally, we land on with data. And I think the point that I'm trying to get is, we can have all the AI algorithms in the world. If you don't sort out your data strategy right, then you will not be able to deliver the best AI outcomes, if you will, or deliver the kind of impact that we talked about at the beginning, right? I'm going to skip this due to constraint of time, but essentially this is a piece of work where for all the data that you have, how do you bring it together and how do you accelerate the building of agents, if you will, without you having to implement your own RAG implementation and so on and so forth, right? And so this is essentially an example of that. On top of this, being able to do things like, well, this is everything that's in Swedish, right? With a few lines of code, I can easily turn this into English without you having to connect to a large language models. And this is some work from Microsoft products that you would be able to see. And so here you'll see things like, let's convert this to English. And in one line of code, Swedish becomes English. All transparent to you. And of course, back end is all powered by Azure OpenAI. Right? So you see us translating it to English. And so one of the things that we've been doing as a product team is to think about, well, how can we take a lot of this latest state-of-art AI models and be able to deliver to you so that AI can be democratized for developers. And in this case, immediately you see an English transcript. And if we let the video play a little while more, we'll take the English transcript and we will classify or categorize it onto, what case of issue was it, right? All leveraging a lot of this latest and greatest open AI model. Now, I'll not show all the video, but I think the point I'm trying to get to is, if we want to get from action to value, that thing that we've been talking so far along is ML code or AI, machine learning models. There's a whole bunch of other things that you need to do on top of this. And this was a paper by Scully. Well, this was written ahead of its time, right? But this whole notion of the technical debt that comes from all our implementations, and you need good people thinking about this problem beyond just AI, but around systems, around distributed system, and about being able to scale it to meet the kind of latency requirements, right? Now, I'll end off with a few things. Is the point there is we all can thrive, and every single role here is being disrupted. New roles are emerging, but one conversation, and this was an article by Andrew Ng, just very recently, in how do we 10x the profession? Meaning for every field that we're in, whether you're a researcher, whether you are a practitioner, right, whether you're a developer, every single field, even doctors as well, right, is how can we 10x our profession through the use of all these tools that is enabled by AI, right? Now, this is, many people are thriving, and we have a lot of Singaporean creators, it's really amazing, right? MDDI has done an amazing work there. Sea Lion, you saw with Leslie and his team, open source models for Southeast Asian language. And of course, A-Star also have their models that's also for Southeast Asian language. This is work by GovTech, AI Practice. The lady is actually presenting in Vancouver this week at an AI conference, right, on a lot of the work that they did around Lion Guard, on classifier that detects unsafe or toxic content. And they have to customize it for Singlish and the local language. And I'll just end off with what is happening in other parts of the world on other projects. And the fun part is, well, a lot of the projects I'm going to show in the next video is all the projects that Microsoft have been working globally across all the different countries. Now you get a sampling of this in Singapore as well, which means a lot of the efforts that we're doing in pushing for AI, building the AI talent, getting people to be able to deploy clusters all the way to inference. We have the talent in Singapore, right? And so us as a community, as a Singaporean community, right, we can thrive with a lot of support system, right? So let's take a look at the video.
We find ourselves in a new era. One where access to information is access to expertise. From the farm to the lab, from the boardroom to the classroom, this new generation of AI is for everyone, everywhere. Now anyone can save time with a personal assistant.
What used to take months are taking minutes.
With GitHub Copilot, I'm saving about 50% of time, and that's time that I can use to do other innovative things.
Anyone can access a personal tutor to learn new skills.
I think this technology has the potential to completely reimagine the way every single student learns in the world.
Pues ahora es como tener a un tutor 24/7.
This is a new way to analyze with a personal coach,
que a gente vai utilizar a IA para ser o nosso coach virtual de saúde para os usuários.
AI is unlocking creativity for us all.
Descriptions are so detailed, in my imagination I can paint the artwork.
ಆದರೆ ಈಗಿನ ಲೆಸನ್ ಪ್ಲಾನ್ನ ನಮ್ಮ ನೀಡಿಗೆ ತಕ್ಕಂತೆ ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಟೀಚರ್ಗೆ ಫ್ರೀಡಮ್ ಇದೆ.
And we are just getting started.
So I think the point that I'm trying to get to is, for many of these projects that you see here, right, and then of course we reflect on the kind of projects that we do on a day-to-day basis, right, we all can make an impact, and more importantly, we all can thrive, right, if we stay on, a learn it all kind of outlook of life, right, but more importantly, having the growth mindset, right? And so you can build what matters, we all can build what matters, and I'll end off with this quote, right, and this is from the recent commencement address, right, that Angela Duckworth did at one of the US universities. She said that in the age of AI, there's a paradox. And the fun part about it is not related to just AI in education, but we often have this belief that, hey, with AI, you don't need teachers. But here, students actually need them more because the teachers become the coach, right? And as educators and, researchers, the role has been even more essential than seeing the role being diminished, right? And so I thought this was a really nice quote, right? And so I'll end off by thank you everyone for your time, but we all can thrive in the era of AI, right? So thank you.
Thank you, Dr. Tok, for the insightful presentation. Our next speaker is Dr. Suranga Nanayakkara, an alumnus of NUS who graduated with a bachelor's degree in engineering in 2005 and a PhD in 2010. He currently serves as an associate professor in the Department of Computer Science at our School of Computing. Dr. Suranga is widely recognized for his groundbreaking work in assistive human-computer interfaces. His research has not only been published in top-tier conferences, but has also resulted in patents, live demonstrations, media features, and real-world impact. In his talk, Beyond Computers, Tech That Sees, Feels, and Remembers With You, Dr. Suranga will introduce us to the exciting field of assistive augmentation, where technology goes beyond function to become a natural extension of how we perceive and interact with the world. He'll share innovations like AIC, which enables the visually impaired to access information through simple gestures, and Moosebits, which lets users experience music through touch. Dr. Suranga, please.
Okay, thank you so much for inviting me for this amazing event. I think earlier we saw the power of technology. My relationship with technology first was when I was an undergrad here at NUS 2001 at KE7 Hall. I heard this sound. What would you do when you hear this sound? What would you do? There's no magic. Yes, exactly. That's exactly what I did. I was in KE7, Block E, opened the door, but there was no one. And some of you might remember this is the Yahoo Messenger sign-in sound. I felt so stupid, right? After all, I'm an ECE undergrad and first year, and then I didn't know this simple thing. But when I really think about it, I was like, maybe I was not wrong. When you hear a door knocking sound, what am I supposed to do? Look at the door, right? But whoever designed that expected me to look at the computer screen. So I started realizing there's a huge mismatch between what technology wants us to do versus what we are good as humans. And I realized maybe to harness the power of technology, beyond as much as we want to come up with powerful technology, there's another important aspect, which is what drives my research, to think about how can we really harness the full potential of technology by designing the right interface between human and the technology. Because this can have very powerful implications. For example, I wanted to go back home when I was feeling so stupid. So the poorly designed technology can result in a lot of, not so desirable situations. Let me show you how we can design technology that is super simple. The culture that I come from, we have this very natural interaction of taking color powder from a container, put it here, right? That is a physical copy paste. That's so simple, so intuitive. So why do we have to come up with new technologies for copy paste in digital world? How can we provide this physical tangibility to intangible digital things so that we can move them around? This is a project I did at MIT about 15 years ago. Here you can see a phone number. I just grab it as if that's color powder and drop it to my phone. It gets copied over. Of course, the data transfer to the cloud, but the point is you interact in a very natural way. This became the basis for one of the Samsung technologies, which became the Samsung Flow, where you can copy from a smartphone to your smartwatch to your tablet. And the other point is, sometimes we think this is, so part of us, we can't live without this. But the point is, if you really believe this is part of you can try this simple experiment. You can open your phone and go to a screen with a bunch of icons and see if you can tap any icon without looking at the viewfinder. It's very difficult. It's not really part of you. Whereas if I ask you to touch your ear, nose, forehead, you can just do it just like that because we had that built-in capability which doesn't extend to this. So the question is, why don't we leverage this amazing awareness of our body to build interfaces? So this is a simple project we did where we thought of ear as an interface. We asked a bunch of people to come and try different parts of touching different regions of the ear. Of course, if you have many regions, the accuracy goes down. But ear as a 3-button interface is not a bad idea. And you can take that and actually try building a prototype. And we actually built a simple proof of concept. So when I get a phone call now, instead of looking at this and disconnecting my conversation, I can cancel the call. I can increase volume of my music, change track without being disconnected from the world. So these kind of interfaces that doesn't require vision can be useful even for people without sight, right? Because these interfaces does not depend on the sight. So we extended some of this work into thinking about how can we empower people without vision. And instead of having to take the phone out, go to an app and take a photo and let your AI processor interpret that image for you, why don't we leverage our natural behavior of pointing and asking questions? So the moment you take the camera out of your phone, put it on your index finger, now you can have a very powerful interaction instead of having to go through those steps, just point and ask questions. This can lead to interactions like read things.
During the next 10 years.
It's not just for blind people because this is just simple extracting information. You can build other use cases such as extracting beautiful things from nature and then use them as a digital paint in your creations. This way you have a lot more connection with the real world and very seamlessly connect the digital and physical. And of course, this size of golf ball size thing on your index finger is not a practical thing. As the time goes on, we offloaded this into a head-worn interface, something like this, where a blind person can simply ask questions.
Baked beans, am I right?
Yeah, correct.
Fair pies, baked bean.
Try this.
Okay. Chocolate chips. Pancake mix. I'm looking forward to the day where I can use the device to increase my level of independence.
So this is pre-ChatGPT era, pre-LLM era. And with the LLM now you can actually have a conversation with these things. You can ask a question, it will respond similar to as if you have a sighted companion with you. Now we build this wearable conversational companion to really empower and provide some independence to a visually impaired person. Here is a simple example of a person is able to now ask follow-up questions.
You are holding a box of PanBio self-test for COVID-19. You are holding a box of Ripple tea.
What type of tea is it?
It is black tea with natural rose petals and extracts.
This is some of the work that has been happening, but my objective for today is really to share some principles that has worked for us, which I think will hold even in the era of Gen AI, for us to do things like this and hopefully get you to maybe start thinking beyond computer box. So I'm going to share 5 things that work for us. One of them is reframing the problem. We always look at the problem and reframe, and that's very important. I'll give you a very simple example to begin with. If I ask you what is 2 plus 5, of course all of you are NUS alumni, this should be simple, right? 7, right? I can ask this question now, I can ask this question tomorrow, answer doesn't change. This has only one answer. But if I reframe this, what makes 7? 2 plus 5? Yes, of course, what else? How many answers do we have? So many, how many? 1 plus 6 also can, yeah, how many? Infinity, yeah, exactly. Now suddenly, reframing the problem, you open up huge creativity, right? Similarly, if I ask you how might I build an effective alarm clock, you will just build an alarm clock one way or the other. But if you just ask, why am I doing that? Because I want to get up on time. And the moment you reframe the question that way, suddenly alarm clock is just one solution. You can come up with all kinds of things, right? You can come up with a bed that throws you out of the bed, or you can come up with an amazing sleep analyzer that analyzes your sleep pattern and then wake you up at the right time, all kinds of things. Just need to reframe. That's what we did. Instead of asking how can we build another smartphone app to enable blind people, we would have just created another app. Instead, we asked how can we enable blind and low vision users to access information. Then we had the opportunity to think beyond just a mobile app. That's the first principle. The second thing is connect and combine. There's this Japanese website called Chindogu. They call this unuseless. They're not useful, they're not useless either, but they showcase combining insanely different things. And if you can actually do that, that's when interesting stuff happens. We thought, hey, can we actually combine a mouse, piece of electronic, and a chewing gum? And yes, you can, and you can then create very powerful interfaces such as this, which is a smart chewing gum that goes into the mouth. When you are riding a bike, your hands are occupied, your eyes are occupied. How do you interact? Either voice, another modality would be something like this. So you can do things like the club is.
He said, let's get out of this town, drive out of the city.
Also, it can help you during your office work or presenting your projects to an audience. Chewit aims to unveil novel users' interaction.
Beyond this, you can do meaningful applications such as for wheelchair-bounded users, where the state-of-art technology is having a joystick that you control with your face. Instead, you can have this, where you look at the direction you want to go and bite on it. So there is a value for thinking of this kind of alternative input mechanisms. How we get that? By combining seemingly different things. The third thing is challenge assumptions. Don't go with the default. When we were given a challenge by one of the largest consumer electronic company, they want to enable first player games on a smart wearable where there's very limited power and very limited power in terms of both battery and processing. So how do you detect gestures? Assumption is to detect gestures you need a camera. And we challenged that assumption. We were like, can we do without camera? So what we did was we looked at very low power, simple infrared emitters and receivers and play with the power and the pattern, and we were able to track the finger and then enable first person games on resource constrained devices such as smartwatches or smart headsets, things like this. principle is we need to pay attention, which is getting increasingly difficult with all kinds of devices distracting us. So paying attention is super important. Why? Because if you just ask people what you need and try to do that, we all know that people say one thing, do another thing, and feel completely different, right? And the classic examples are, Henry Ford said, if I asked people what you want, they would have told me, we need a faster horse. If Apple asked people what kind of phone you need, people would have said, hey, I need a phone that has a bigger screen or longer battery life. People are not the experts. Users are not the experts, right? We need to have the eyes, the sharper eyes, and the attention to catch and observe and see where we can really add these delight things. There's a very famous diagram called Carnot diagram, which talks about the users. For example, if you take the iPhone as example, prior to that, if you had increased the battery life or the screen size, the performance would have linearly gone up, right? If you make the latency of the call very, very optimized, those basic features, more you optimize, doesn't add much value. The moment they came up with multi-touch, all of that became a delight feature. Now that has become a norm. So then whoever kind of observe and come up with the next delight feature will be the game changer. And for us, we did observe that. When I was at MIT, the basis for that AIC project was that I had a friend who's blind. For him, it was just fine. He was use his phone, take the phone out, get his app open, and then scan. He get the outcome. He figure out what's in the lecture notes or what's he's holding. So he would have never reported a problem with that. But I observed that, oh, this has so many steps. Why he had to go through these steps? Can we cut down, make it intuitive? That's how we came up with the finger reader, which became IC. So paying attention is important. Fifth is, I think this is also super important, which is making things happen. The mindset, this is sort of a mindset thing. Instead of thinking of solving a jigsaw puzzle, which I don't think that's interesting for two reasons. Firstly, even if you solve, there's nothing new because you knew the solution, how it looks like anyway. Secondly, if you actually run out of a piece, you are stuck. So instead of having that mindset, have the cloth maker mindset. Whatever the pieces you have, you bit of improvise as you go. Firstly, you yourself will be surprised the kind of output you generate. Secondly, you will never run out of pieces. Because when you actually do a project, usually what happens to us is, or you think you have the newest and coolest idea, you want to check what others are doing. Oftentimes you find, oh, others are doing similar stuff. So what do? Do we throw away? No. We can always find spaces. I mean, if you look at the IC that we are doing, yes, there's a lot of people doing smart glasses and all these things, but I think there's a space for us. There is a space for smart headphones, and especially with blind people, the stereotype of blind person being, dark glasses, that's not how a lot of blind and low vision users are. Sometimes you can't even tell them that they have low vision. And there's personal preferences over glasses for some people to use headphones. So we are kind of opening up a new space of smart headphones. So yeah, those are the 5 things: reframing the problem, connecting and combining very unusual stuff, challenging assumptions, paying attention, and then making things happen. And there's a 6th piece, which really, for me, the key thing for us to do these things over and over again and really, live through ups and downs, is really this has to be a fun process. I think fun supersedes everything. And when you have this kind of serious fun, you generate impact. And for us, we are far beyond generating papers. Of course, the work we did, we were the first ever Singapore team to produce a paper in this prestigious conference for human-computer interfaces. We contributed to the World Intellectual Property Technology Trend Report. But that's just one piece, because we are having fun building stuff, solving problems, reframing problems. We do other stuff. We build these lights for Singapore deaf swimmers, where the existing light from all these big companies were something like this, and as a deaf person I need to position like that and look at this. When the light goes up, I jump this way. It doesn't work. So we came up with this light that's adjustable, that gives them the anticipation with the orange, and then when the gun goes, it turns green. This is connectable to any professional timing device, and this is used in 2016-2017 National Deaf Games in Singapore. This is the actual National Deaf Games. So you can see ready, and now simple device we did, which is detecting sound or vibration, turn that into light. Research paper in 2013. Because we had fun, we worked on that for another 5 years. Now it's a commercial product in Singapore that helps deaf people to be aware of if someone is by the door. It's a smart doorbell for deaf people. It requires that 5 years. Unless you have fun, you won't do that. And for IC, which I started as a postdoc 13 years ago, still happening. Still now, 2025, just last week, we got the contract that Singapore Botanical Gardens will be the first UNESCO site that will enable blind people to navigate on their own, experience the botanical garden. Not only that, there will be blind people who works as a guides in the Singapore Botanical Garden, supported by SG Enable. And now for that, we spun off a NUS startup supported by our graduate innovation program as well. So that's because we have fun doing stuff. And my own PhD, ECE 2008, which converts music into vibration for a deaf person to enjoy music. 2008, we collected data, had a paper. Now it's been more than 15 years using this in the school as we speak. And then whenever I'm in Sri Lanka, fix this and make sure that this is running, because this is so much fun to interact. Yeah, and lastly, this is a note that a lady from Hamilton gave me. We gave her this wearable device for them to feel music. She became deaf in her 20s. She said for the first time she drove from Hamilton to Auckland after she became deaf, because now driving became fun again. She said, "You should have seen me dancing in the car." This is not for research purpose, just a note that she sent in appreciation. So I guess when you apply those principles and have fun, you create amazing level of impact. And I'm mostly the spokesperson of this work. This is all through lots of hard work through my amazing team over the years. Yeah, we have fun doing this. I hope you had fun listening to me. Thank you so much.
Thank you, Dr. Suranga. We will now open the floor for questions from the audience. To ensure everyone can be heard clearly, we kindly ask that you use the microphones provided along the aisles when asking your questions. We invite Dr. Tok back on stage as well. Thank you.
Questions? Okay, there's one question over there.
Hello? Okay. That might be a little too loud. Okay, first, thank you very much for the excellent talks. It's been wonderful hearing about all the progress we've made and hearing all the different perspectives. I'm very curious to hear a little bit more about the flip side. In particular, one of the things that shows up every now and then in media, and I have certainly experienced when I'm trying to use AI for different things, is that it oftentimes gets things wrong. And sometimes it's not really material if you're just using ChatGPT and You just ask it a question. It's like, hey, what's the population of Singapore or something? And it will say, 20 million. Well, then we sort of know what's wrong. We don't really care. But in particular, if it's a disabled person who's using it to navigate through the world, or we're using it for code that goes into production and could have an impact, how do we mitigate these with systems that are as black box as AI often is? How do we deal with the failure cases? And there have been a number of failure cases that are very famous in the media. So I'll just leave that as an open question.
I think it's true, like in a lot of this kind of discussion or this kind of forums, we often show the positive side of it, right? And of course there are practical cases where reasoning does not solve, right? Or in fact, people questioning, is your large language model just a good stochastic parrot, right? Or it's just regurgitating things on all the information that you have seen. I think two parts to it, right? One, you could approach it with a growth mindset, or you could approach it with, well, it does make mistakes, right? So for example, in the notion of like the coding example or the coding agent example I gave you, right? We have been doing like pilots, etc., with the engineering teams, etc. I think that we saw different groups of developers. One group, their feedback was, well, the code it generates is not even half as efficient as what I write, right? And so I don't think the coding agent will help me in my day-to-day work. And we also seen the other set where developers are sharing to say, well, simple things like, well, yesterday I was asked by my manager to remove all the to-dos in all my code as comments and remove it. And he submitted a PR that says, Copilot agent, go remove this, or write a script to do it. And Copilot agent did it first time wrong, and you iterated with it. And he was able to do what used to take him 1 or 2 days to a few hours. So in that specific set of developers, their day-to-day life has improved, and of course then they could do other things much better. So that's one data point, right? And then there's the other data point I remembered, like probably about 1 year plus ago, not Microsoft, but one of the tech companies demonstrated on stage where one of the demoers was saying, well, tell me about my revenue and my profit and the margins, right? And the whole internet went viral because it was doing the sums and the average wrongly, right? Fast forward a year from now, a lot of those have changed. And of course, there's guardrails that's in place, there's way to ground the data, and so on and so forth. And technology has improved. My main point is, if you see the agents or the coding agents or any agents for that matter as just another human, right? Humans do make mistakes, agents do make mistakes. And it's us being able to coach and being able to get them to steer them in the right directions, right? Including, for example, sometimes you'll hypothetically conjure up nations or numbers that you've not seen before, right? But be able to ground them and be able to see them as just a first pass of things, and you want to get a second opinion, or you want to get a second opinion from another agent that will cross-check the first agent. I think the pace of technology has evolved so fast that a lot of those gaps and pain points, if you will, that you see today is slowly going away, and then it's a matter of using it as per your interacting with any other subject matter experts that could be wrong as well. And so that's how I look at that space. But one thing, and Ovi was there probably about 6 months ago, right? We're in Bay Area, and same thing, like we had a panel of people. We are all very passionate about AI, and the president, Prof. Tan, was there, right? And I think he reminded all of us at that point that while the progress of AI has been really exciting and is indeed solving some real-world problems, us as whether it's practitioners or researchers and so on and so forth, foundations are important, right? And being able to have that foundation would help us leverage AI much better, right? Just as a case in point, right? My son is 18, and 2 years ago, and that was in the early days of coding agents, he wanted to write a website, And I did not have time to teach him to write a website and so on and so forth. And so I said, go just talk to ChatGPT. And ChatGPT did create a website connected to a database and was all operational. But because he did not have the foundations, he did not understand a single line of code that was there. And so he did not know how to debug. His debugging was interacting with the agents. And I saw firsthand that if he had learned programming methodology and had the foundations on, programming construct and so on and so forth, he would have been able to interact with the agent better and be able to do better code, right? And so that is happening. And so like as us in the school, even at work and so on and so forth, I think while we rely on some of this tooling to help us do our work better and so on and so forth, being cognizant or thoughtful of the fact that we need to build strong foundations is important. And so Prof. Tan gave us really good advice, right, during the alumni meetup, probably about 6 months ago, right, in the Bay Area. Yeah.
To touch base on the second point, because I think vibe coding has become a thing.
That's right.
But you can only go so far, right? It's nice to be able to prototype, but the foundations are so important.
That's right. Yeah.
And that's exactly why I think the School of Computing, we still have a strong or rather important role to play in terms of, having people, given with the right, the basic skills so that, then you can get the full harness of these powerful tools. That's one point. The second point is when you actually build these systems and products, the human-centeredness has to come into play, right? I mean, do we want them to have completely autonomous way, or in certain situations have them done in a way that there's a human using this power of these tools still sort of driving towards the outcome?
Yeah, and I think even to put that in perspective, there's recent studies, and some of you might have read those studies before, in some of the universities, some in Asia, some in other parts of the world, where their students are given programming assignments. They do it very well, they excel all the way. But when the lecturers gave them paper programming assignments, or even practical tests where they have no access to any of these tools, all the students failed those practical exams or the paper tests, right? And to the point that the foundation is important, because the state of AI today, and of course it's accelerating at a very fast pace, I would see them as tools that enable us to do things better. But without the foundation, these tools itself are just tools, right?
Thanks for the great presentation. My question is to Dr. Tok Wee from Microsoft. From your presentation, you kind of walked us through some high-level summary about the data centers and what's happening around the LLM space. With a lot of data that is required to run these large language models, and these are just initial stages. We're getting, just getting started with this. With the evolving nature of technology, what we have seen is it becomes more viable. It becomes more compact as we proceed. Moving into small language models, and as we evolve into this, do you see that the demand for the data centers would actually eventually go down at some point in time, or would get stagnated?
That's a good question. There are giants out there that want us to believe that the GPU needs to get bigger and bigger, right? And there's also a lot of work done within the research community on. So there's two problems, or a few problems, right? There is the pre-training, right? And then there's the post-training. But more importantly, it's getting this model ready for inference, right? So and you need larger and larger GPUs, or more and more powerful GPUs. In fact, what is interesting, if you've observed some of these keynotes, the first thing that they will come on stage is, we are so excited that we are announcing the fastest ever seen GPUs. And then 6 months later, the same thing repeats and so on and so forth. And of course, there's this global mad race on procuring GPUs for usage, whether it's academic or commercial. And then there's the other space of small language models, or varying size language models, right? And so I could look at it from a commercial lens, or I could look at it from just looking at the wisdom of people across time. Is that if you recall, in the very, very early days when this field or word AI became popular, right, in the areas of machine learning, or we call it classical machine learning, right? People were chasing for super duper classifiers, right? And we finally concluded it doesn't exist because you can't have one size fits all. And what is happening, like even if you look at the past solutions for Kaggle competition in the last 10 to 15 years, and all of them post their solution kernels online, all the top winning solutions, all users an ensemble, or with a mixture of models, right? And so that begets the question, it's not just a small language model thing. It's a matter of, well, you will never have a super duper uber expert that understands everything. You will likely be a mixture expert. And if you see recent work that has been published, there's been a lot of work talking about mixture expert. And in fact, DeepSeek, the latest version of it, was also a mixture of expert. But it's not just about a mixture expert, it's about the practicality of, if you're deploying the model and you're serving it at an infinite scale, how can you parallelize the work? And how can you save on activating the right set of models that will be able to answer the questions, right? So the small language models conversation definitely started, like Microsoft started it. A guy called Sebastian Bubeck, who is now with OpenAI, but he was with Microsoft Research. He came out with this thing called the Fine family of model, and he wrote this paper called Textbook is All You Need, right? On how we synthetically generate data that's of high quality, that is able to train the small language models. So that's one perspective to it. The other perspective to it, which is very practical today, is for a lot of the problems that we have day to day, you don't need to use such huge models, right? Like domain-specific models. For national security reasons, for a lot of various reasons where the models need to be on premises, you don't need the large models to serve, and so on and so forth. And so there's still been a lot of work on it. In fact, in Singapore, there's companies deploying small language models to meet the needs. But then they are also exploring how do you have this continuum of small language model to a certain point where it cannot reason to what you need, and the transition to a large language models offered by an API in the cloud. And how do you make this so transparent so that the customers or the users doesn't feel it? And so there's all this different piece of work that's happening. And on the Microsoft front, one of the things that we launched just at May this year is this thing called Foundry Local, which is essentially saying, take all these models and how do you get it to a point where it can run on your laptop, for example. It's all happening all simultaneously at the same time, depending on how you slice and dice at the problem, right? Yeah. Yeah, this question.
Hi, thank you for the sharing. Okay, I have a question. Okay, so given that training a single large AI model actually can emit a lot of data, carbon emissions. Like I heard, like it's equivalent to driving a car for 1 million kilometers. So do you think this will result in intergenerational opportunity costs? And if so, what are the things that are implemented to improve the cooling efficiency in data centers, especially? Thanks.
Not my domain of expertise, but I think you're talking about, I teach a class on human-centered AI. We touch upon some of these, it's not essentially a technology program, right? There's also the other aspects of ethics and the regulation. I was looking at the EU principles of responsible AI. Right? They talk about AI being robust, AI being lawful, AI being ethical. So I guess they talk about 2/3 of AI development and thinking is beyond technology aspect. I guess you're talking about the sustainability, the responsibility aspect. I guess part of that is beyond technology. Part of that is collectively how we want to advocate for policies and other considerations. Right? I mean, that's how I think about it. And I think there's also a responsibility for us as a community to Do we want AI to drive us to whatever it wants us to go towards, or rather we want to advocate for the future we aspire to be? Right? So I'm coming from non-AI background, more from human AI, rather human computer interaction background. I'm sort of the other camp. Rather than letting AI drive us, I'm trying to show this is a more meaningful use cases of AI, and then can we drive the development and the progression of AI towards that. So that's one view. That's sort of my personal take on that.
Thank you.
Yeah, there's one question here. There's a button to switch on. Yeah.
Thanks for the exciting presentation. I have a very simple question regarding my interaction with Copilot. Yeah, I just last week I gave Copilot a task. I said, may I give you 6 restaurant phone numbers in Japan? And because a lot of these restaurants, they don't take online reservation. You have to physically call them, speak in Japanese, and make the reservation. So I asked Copilot, I said, can I give you this list of numbers? Can you call on my behalf and make reservations? And Copilot couldn't do it. It says, I can turn the script into Japanese in an excellent, polite form, but you have to call yourself. So I'm just wondering when will there be a possibility that there will be a true personal assistant that can do all the dog work for me?
I think it's a very interesting question. Few things, if you recall, if you look at the Google I/O conference probably about 3 years ago, Google demonstrated something called Duo. And at that point, the demonstration use case that they showed, right, was not Copilot, because at that point Copilot doesn't exist, asking Duo to make a appointment at a hairdressing salon in a different language like Spanish. And of course Google demonstrated that, but they never shipped it, right? And today it's true, like I use Copilot, all different kinds of Copilot, not specific just to Microsoft, but many other versions of it as well. Not just even that calling the restaurant problem, like if you could ask it to generate for example, a birthday video, it will, after a long interaction, it will tell you, I cannot do it, you have to use other tools, right? So the challenge and the pain that you described is very real today, right? But there are a lot of people trying to make Copilot useful to be able to address that. And so one thing that is very exciting in the space is now there's this notion of what they call MCP, or MCP servers, or Model Context Protocol servers, right, and agent-to-agent interactions. And given how fast technology is evolving, and what it simply does is that you have a Copilot, imagine your Copilot is an agent, and the agent is now able to invoke tools on your behalf, right? And some of these tools could be doing things like text-to-speech, right, and be able to observe the interaction flow, right? At the pace the technology is evolving, it might get to a point where you could do that. But you're right, the pain that you described exists today, and it has never been fully commercialized. Not sure what your thoughts are. Yeah.
Okay, just to continue, then I gave a Copilot a separate task. I said, okay, I need to drive from point A to point B. Can you calculate for me how much road toll I need to pay? Because I don't know the environment, I don't know what's the toll fee, it could only give an estimate. It couldn't actually work out the actual road and then calculate the toll. But this information is available on the internet. It's just that I don't want to do the dog work. So, but you wouldn't do, you just do an estimate, which I can estimate myself.
No, 100%. Like the pain is true. And what is also interesting is that's why there's that discussion around general purpose chat that seems to understand the world and domain specific chat, right? And so today a lot of organizations are building same set of Copilot experiences, but they're grounding it to the data that's available that makes it more accurate. Just as a case in point, that already have been fixed in some of the ChatGPT experience. I remember someone showed online, and some of you might have seen it before, and they say, hey, what is 1 plus 1 or 2 plus 2 or 3 plus 3? And the internet was gloating on the fact that it could not solve the problem. And then there was a further interaction where the thing said 1 plus 1 is 2, awesome. And the person said, no, it's not 2, it's, I think 1 plus 1 is really 3, right? And then Copilot goes on to the interaction and say, why is it 3? And then the person was just being cheeky. Said, my wife said it's 3, right? And then Copilot said, yes, your wife is right. It's exactly 3, right? And that was the time when they were trying to demonstrate that Copilots, the general form of Copilot, was not able to do mathematical reasoning and solve. Now, case in point, fast forward 1.5 years from now, it is solving international math Olympiad problems. Now, there's still two schools of thoughts. Terence Chow, who is one of the guy that's recognized as one of the greatest mathematicians, did actually comment on it that it's actually not thinking as well. But he was also amazed by the progress made in the notion of reasoning, or does it truly reason? And to your point, like the calculation of distance, or even doing simple math, or even day-to-day finance, bookkeeping stuff, there's been a lot of work on not just treating it as a generalized agent, but building on, leveraging a lot of the software engineering design principles that we have, where they build around it, where the agent is just one part of the experience, right? But either they turn the generalized agent and ground it on data that it understands, so the answer gets more. And to your point, it's not just about tools and things like that. This is very important in commercial application, especially if a listed company and you want to say, hey, what is your revenue forecast for the next 12 months? It better not be wrong, or it better not hallucinate. And there's been a lot of work done through a lot of this recent architecture that's not just the large language models, right? To ground it to data so that it is able to give meaningful reply, and with the guardrails around it to make sure that it doesn't stray. It's an interesting conversation because with the guardrails around it, the LLM actually become more stupid, right? But it's more accurate. Then the question, or the philosophical question, is, do you want an LLM that's not as unbounded, they can imagine the skies of the possible, or whether you want it to be relevant to the company data so that it can really build the trust with the end users, right? And that part about grounding it with the data and having the guardrails, today a lot of companies are already building that. And so, for example, this afternoon, as I was telling you, I spent time with one of the local SI where they were reviewing some of the projects with me. And they were sharing exactly some of this works around using not just Copilot, but Copilot equivalents, if you will, in things like ops and data ops and operations. And they also encounter similar problems as well. But the way they do it is to build an application layer on top of it, right? And so in your problems like around toll and things like that, it sometimes can get very frustrating. I get frustrated as well. But it's because we're all using the general purpose Copilot experiences. And it turns out that this space of being able to ground it or being able to fine-tune it based on your organization data is a very lucrative space. So as you saw, OpenAI, besides offering OpenAI, is now offering millions dollars consulting projects if you want to engage them to do it based on your data. Right? So it's also a very lucrative business model that some of the Singaporean companies are also starting to see it as a space. Right? Yeah.
Thank you.
Hopefully that helps. Yeah.
I had a quick remark to that. I think while I understand and appreciate the fact that you can offload everything to a machine, including calling the restaurant, do I want that? Then what happens to my person-to-person interaction? Do I not want to call a person and have that interaction? So I guess, do I want everything to be offloaded, or do I want to work with AI to accomplish my tasks in a more efficient way? Right? So there's two ways, right?
But what I've seen people that do very useful applications, right, was instead of calling restaurant, etc., one thing that frustrates, not sure whether you have the same experience, you call a support line, it says press 1, press 2, press 3, and then it lets you listen to very beautiful music, but you never get to talk to someone, right? I've seen someone as a hackathon project done by a student somewhere in China, right, to automate that and to listen to a point where you can figure out a human, then it hands it over to the human, right? But the 30 minutes of waiting on it was all done by an agent. That was it actually won the best hackathon for the specific universities in China. It was very amazing. Yeah.
There's one question over here.
Probably I can project my voice. So thank you, Dr. Tok and Dr. Suranga for sharing. So now people all think about AI is so happening, and people are, if you don't use AI or don't be part of the AI, your knowledge is out of date. So what is your one sentence advice how we can be part of it? Instead of people think, oh, AI is very cheap, people in academia or people in industry know it, but how everyday life of us can be part of it?
You want to start that?
I think for me, this idea of AI replacing us is still super far-fetched. I think what's important would be those who know how to use AI to get things done in an efficient and meaningful way will have an advantage. And again, if you think you need that skill, as a university, that's part of our responsibility to provide that upskilling and reskilling. We have all kinds of things. I guess my advice is, if you have the confidence and the foundation, you can self-learn. If you don't have that, you can have coach or professional give you that awareness and the skill, because having that is going to be useful. Completely ignoring AI and thinking that I can survive may not be the most wise thing. Also thinking that AI will do everything and do nothing will also not be the right thing. Giving you enough sort of foundational enough skill and either self-learn or take some of these courses around the basics of things will be of value. That's my simple advice.
I think I felt like much as so few things have changed, right? Like the technology progress has significantly accelerated, right? Which means we're all overloaded with information. Even choosing what to learn is a big thing, right? But I felt like the continuous learning is important. But on the job learning, which is for some problems that you have, having the curiosity to say, hey, let's try it out, whether it's going to make you better, is important. But I think I felt like it's not an AI conversation, much as we want it to be an AI conversation, right? If you look at the whole evolution of technology over the years, right? At any point, there will always be a tipping point where technology is enabling you to do great things. Right now, just at this point, it's AI. Tomorrow, it could be, fast forward 5 years later, maybe it's quantum, for example, right? And it's how and our attitude towards, well, this technology change will always continuously evolve, and it's going to change our life, right? And we just need to make sure that, hey, we're able to, say in the case of a job, is be able to continuously learn, so how can it solve your existing problem better? I think that's one. Two is, I've seen situations where, for example, we all have different domain knowledge in different fields and so on and so forth. But that domain knowledge is yours and it is important, right? But there are folks that have no domain knowledge that are able to come in. They might fail and they might try again, and they might fail and they might try again. And so for folks that build up the domain knowledge over the years, those are precious things that people are not going to get immediately using AI. And so I think there's this whole interaction between seeing technology as just that change as a constant, right? But at the same time, keeping ourselves updated so that we can know the right question to ask, someone that can give us the help, right? Yeah.
Thank you everyone for your questions. Ladies and gentlemen, please join me in a round of applause for our speakers for this very interesting discussion this evening. Thank you, Dr. Tok and Dr. Suranga. Professor Mitra will now present a token of appreciation to our speakers, Dr. Tok and Dr. Suranga. Professor Mitra, please.